Okay, assignment 20A, problem number 3. We have two curves, or a line and a curve. The first one is this line, which is x equals 5/3 y. Everything's in terms of y, a little backwards. We have this other curve, that's x equals square root of 1 plus y squared. And then this is region S. First question was to find the coordinates of P, where they intersect. So I just set square root of 1 plus y squared equals 5/3 y in my calculator. Remember when you're solving equations like these that have y's in them, or even integrals that have y's in them, when you're on your calculator, it's just a variable, so just call it x. So I just dumped this on my calculator, and I got 0.75. Just be careful though, because your calculator is going to tell you x equals 0.75, but remember we're solving for y, so y is 0.75. I plug that back in, got the 1.25 for x, so there is my point of intersection at point P. Next question said find the value of dx dy for this curve at that point. So I just took the derivative. By the way, you could do this on your calculator. You could just put this in your calculator, call it an x, and say find the derivative at x equals, which would actually be y, in this case 0.75. But it was pretty simple, so I just did it. Took the derivative, 1/2, times 1 plus y squared, so the negative 1/2 times 2y, and then I plugged in the 0.75. So I got a slope of 0.6. Part B says set up an integral and evaluate it. So that finds that area. So I'm going to draw my rectangles this way, horizontally. It makes more sense because the same curves on the right and left, as well as everything's in terms of y, right? So now the width of the rectangle is dy. It's just right curve minus left curve. There's your right curve. There's your left curve. Right curve minus left curve. We're going up from here to here, which is from 0 to that 0.75. Just dumped that in my calculator, got 0.346. Part C says curve C is part of the curve x squared minus y squared equals 1. And then they're asking you to change that to polar. And they even tell you what the answer is supposed to be. This is the answer. So just remember that x is r cosine theta, y is r sine theta. So I'm just making those substitutions. So I get r squared cosine squared for x squared minus r squared sine squared equals the 1. I factor out r squared. I get cosine squared minus sine squared equals 1, and then I divide it through. And then they asked me to use that equation to find the area of r, or not to find it, but to set up an integral in polar. So remember, polar form is 1/2 r squared. So the easy part is 1/2 r squared. There's my r squared, which you could get even if you didn't do this problem because they gave it to you. So 1/2 r squared. I just need the points of intersection. So remember, we're trying to find this area. So we're going from here, and we're sweeping this angle to right there, right? Then we're going to stop right there. So the question is, how do I find that angle right there, right? Because I'm going from here to here. Well, this angle is formed by that line, right? So if you remember, that line has a slope of 5/3. So there's my work. Excuse me. It's just a tangent inverse. This point here, we just go x, y. So tangent inverse, we go to our tangent inverse of y over x. It's actually 3/5, right? Because this is x and y, so this is the same thing as y equals 3/5 x. So it's a tangent inverse of 3/5 to find that angle, which is 0.544, and then just plug it in there. And it actually asked me to find the area, but one cool thing you could do, you could check it, right? You could check this area to make sure it's the same as you got here. So that's it for that one.